So let's go over linear models now. We'll do a high level overview and then we'll go into some models. So for the linear models, fundamentals, right? Let's go ahead and talk about fundamentals, right? What does it do? It predicts a target Y as a linear combination of input features where Y equals where Y where Y is equal to big beta 0 plus 1 x1 plus x2 plus dot dot dot, right? Let's make sure that that's clear. It keeps going, right? Plus big beta p xp, right? So some combination of input features, and it's a linear combination. So it's like y equals mx plus b, right? That's what it's sort of mirroring, right? Um, so that's the general formula for it. Okay, now for fundamentals, right? We can continue with fundamentals. It's used for regression, right? Like continuous values in classification in the categories, right? So those are the fundamentals, right? What is a linear model? It predicts a target Y as a linear combination of input features big beta 0, big beta 1 plus big beta 1 x1, b2 x2 plus so on and so forth all the way to bp xp, right? So that's what we're dealing with. Um, so now let's move on to another core idea here about linear models or loss functions, right? So, and why do we have it? What is a loss function? A loss function measures how, I'm gonna put this in bold, how wrong the model's predictions are. The model's predictions are, right? So training is equal to minimize the loss, right? So we can go over common loss functions. Actually, yeah, we'll do common loss functions. I'm kind of getting in the way here. Let me see. Um, how can I? There we go. Get the linear models in there. Okay, common loss functions. Um, so we have squared error. We have squared error. Um, RSS, MSE, mean squared error, right? Regression. Oops, sorry. Regression. And then we have logistic loss for classifications. Okay. And then we have hinge loss. And that is for margin-based classification, e.g. SVM, support vector machines. Okay, so uh, so that's loss functions, and so that's key because that's gonna be part of our, let me see here, our overall equation. We'll get another sticky note here. All right, let's get another sticky note. So we have fundamentals of linear models. Fundamentals of linear models, right? That's what we're talking about here. All right, now let's talk about, so we had loss function core idea. Now let's talk about key regression models. So key regression models. Can't type today. Key regression models. Ordinary least squares, right? It minimizes the squared error, no penalty. No penalty. I'll put that in bold. No penalty, right? And then we have ridge regression. Oops. You know what? We can bold that too. Ridge regression is the next one. And that uses L2 penalty. That's what we call it, an L2 penalty. And it shrinks the coefficients and keeps all features. So ridge regression, L2 penalty, shrinks all the coefficients, but keeps all the features. And that's different than lasso regression. Lasso regression, L1 penalty. L1 penalty forces some of the coefficients to go to zero. Okay, so, and this can be also called feature selection, right? Maybe there's cases where there's features that we just don't need. If we're talking about diabetes, you know, uh, height and weight might be important. Other biomarkers might be important, but something like their total income may not be important. Maybe if we have like data that's got a whole profile on them, and so we could just do some feature selection and do some lasso regression um, to get the income portion to go to zero. And then we have a combination. Oops. Elastic net, which is L1 plus L2. It's a balance between the two, between ridge and lasso. Okay, so ordinary least squares minimizes the squared error. There's no penalty. But then ridge and lasso both have penalties, right? Um, with ridge, we're shrinking all of the coefficients. But with lasso, we're just zeroing out some of the features. So we're just doing we're trying to make the model more conducive for regression. And I think I'm going to stop there and we'll continue fundamentals of linear models in the next video. So See you then.